So in this class, we are going to discuss electrolytic cells and electrolysis, Faraday's laws. So this is a small at very important topic, and continuation to this topic we'll have a discussion in tomorrow's class. So in this class, we are going to focus mainly on what is electrolysis and Faraday's laws. So before going to that, what are electrolytic cells? Electrolytic cells and electrolysis. So in the previous classes, in the beginning of electrochemistry, we have discussed about electrochemical cells. Electrochemical cells are galvanic cells. What are galvanic cells? So galvanic cells which converts chemical energy into electrical energy. They are called galvanic cells. Such devices are called electrochemical cells. Now, here what you are seeing on the screen is electrolytic cell. So there is a small difference in the pronunciation. See, don't be confused. Electrochemical cell, electrolytic cell. Okay, don't be confused. Electrochemical cell, in electrochemical cell, during a chemical process, that is a redox reaction, um, chemical energy is converted into electrical energy. Such devices are called electrochemical cells. In electrolytic cell, it is such devices which uses electrical energy to bring about a chemical change or a chemical reaction. See, that means for a chemical reaction to takes place, it needs some energy, no? So generally it uses electrical energy for a chemical reaction to takes place. Such cells are called electrolytic cells. Okay, and to make you understand, I'll take a small example of this. Okay, one second. Okay, see here, let me take one second. All settings are changed. Let us take a beaker in which some salt solution is taken. Say for example, sodium chloride, NaCl salt solution is taken in a beaker, and after that we have arranged two electrodes. Let it be two, these are two electrodes and connected to battery. This is a positive end and a negative end of the battery. Negative end of the one, this is a battery. So when we switch on the battery, what happens? Electricity flows into the solution. When electricity flows into the solution, this whatever the compound or solute we have taken, it dissociates into Na plus and Cl minus ions. Say for example, this is a fused NaCl, sodium chloride in a molten state, in liquid state. When electricity is passed into NaCl, it splits into Na plus and Cl minus ions. Here a chemical change has happened. That means sodium chloride decomposed into Na plus and Cl minus ions. So how this chemical change happened? By the passage of electricity. This is called electrolytic cell. Here if you take hydrochloric acid in the place of HCl, in the place of NaCl, when electricity is passed through HCl, HCl splits into H plus and Cl minus ions. If you take some other compound like copper sulfate, CuSO4, and when electricity is passed through CuSO4, CuSO4 splits into Cu plus 2 and SO4 minus 2 ions. That means when you pass, when you send or pass some electricity through any chemical substance, that chemical substance decomposed into its component ions, constituent ions. So this process is called electrolysis. This process is called electrolysis, and the process in which electrical energy is used for the conversion of for a chemical reaction to takes place is called electrolytic cell. So that's a simple thing, simple difference. So I think I hope you understood what is electrolysis. Shall I take one more example? What is electrolysis? It's an important term, electrolysis. We use many times this word electrolysis. So very important. It's very simple. We have taken a beaker and filled with some substance. Say for example, this time I am using potassium chloride. Potassium chloride. I'll make this concept little easy by taking one more example. So potassium chloride I have taken, and here two electrodes I have taken. These two electrodes are connected to battery. This is a positive end of the battery, and this one is negative end of the battery. That means one is a positively charged electrode, negatively charged electrode. So when we switch on the battery, what happens? When you switch on the battery, the current enters into the cell. The current enters into the cell, then potassium chloride splits into K plus and Cl minus ions. So these K plus ions are cations and Cl minus anions. So positively charged ions, cations. Generally, do you know in which direction these positively charged cations move? Cation move towards cathode. Cations move towards cathode, which is negatively charged. Anions move towards anode. Anions move towards anode, which is positively charged. Don't be confused. In the previous classes, in the beginning of electrochemistry, we have discussed about these galvanic cells. In galvanic cells, zinc, copper, and such electrodes we have taken. Here, this is the anodic part. This one is cathodic part. Their anode is given the symbol negative. Cathode is given the symbol positive. Means anode is having negative charge. Cathode is having positive charge. This is in the case of galvanic cell. But in case of electrolytic process or electrolytic cells, these symbols are reverse. Cathode is given negative charge. Because why cathode is negatively charged? Because the cathode is connected to negative end of the battery. So this electrode which is connected to the negative end of the battery, it is considered as cathode, which is having negative charge, and these cations move towards cathode. Positively charged cations move towards cathode, negatively charged anions move towards anode. So that's all very simple. And if you can remember one simple point, that cations have positive charge, so they move negatively charged cathode. So don't be confused. And similarly, anions have negative charge, so they move positively charged anode. Okay, don't be confused. So that's all very simple. So here, in most of the cases, during our coming explanation, I will tell. So metals have positive charge. Means metals form cations. Metals forms cations. So they always move towards cathode. So metals will be deposited, or metal ions will be will move towards cathode, right? Generally non-metals have negative charge. That means anions, they move towards, they are anions, they move towards anode. Clear this point? I told you many times, you please note down the things whatever you are listening here. Okay, so cations move towards cathode, anions move towards anode. So when this is happened, when we send some electricity into the solution, or a fused substance, then it splits into ions. So this is called electrolysis. What is electrolysis? It is the process of decomposing a substance into its constituent ions. A process of decomposing or breaking down a substance into its ions by passing electric current is called electrolysis. During electrolysis, whatever the ions formed, they move towards oppositely charged electrodes. That means cations move towards cathode, anions move towards anode. Okay, this is very basic thing, and uh, this part of explanation will not be there in your textbook. So this is a very fundamental concept. Next, we'll see. This is the definition. Definition will be helpful for you in board exams. But when it comes to competitive exams, you should understand what is electrolysis. Okay, what is electrolytic cell? It is a cell in which chemical change takes place due to electric current. It is an electrochemical process. And what are the uses of electrolytic cell? Electrochemical process is one of the greatest important aspects in the laboratory and in the chemical industry. For example, in the extraction of metals from ore. This is one simple example. So metals can be extracted from ore by using electrolytic process. Next, here is one small and important concept. All of you please note down this, and the importance of this concept will be more in the coming discussion. 1 mole of positive charge is required to neutralize 1 mole of electron. 1 mole of positive charge is required to neutralize 1 mole of electron. Here 1 mole of electron means 1 Faraday of current. 1 mole of electrons means 1 Faraday of current, or 96,500 coulombs. That is the value of one charge of 1 mole of electrons. So what is 1 mole of electron? Do you know the charge of 1 electron is 9.1 into 10 raised to minus 19 coulombs. If you don't know, you please note down. Okay. Charge of 1 electron. Charge of 1 electron, see. Charge of 1 electron. Charge of 1 electron is equal to 9.1 into 10 raised to minus 19 coulombs. That is the charge of 1 electron. Okay, 9.1 into 10 raised to minus 19. 1 mole electrons means 1 mole electrons is equal. What is the value of 1 mole? 6.022 into 10 raised to 23 into charge of 1 electron is this. So 9.1 into 10 raised to minus 19 coulombs. That is equal to approximately 96,500 coulombs. Do you understand, dear students? This is a very important point. So what is 96,500 coulombs? Actually, this is the charge of 1 mole electrons. Charge of 1 mole electrons is called is equal to 96,500 coulombs. It is also called 1 Faraday. This is equal to 1 Faraday, simply 1 F. Okay, suppose if I give you one small reaction, okay, now I'll show you on the screen. Okay, remember this, 1 Faraday is equal to 96,500 coulombs. This is nothing but charge on 1 mole electrons. Next, few examples I am going to give here. Na plus 1 electron gives Na. That means what? Sodium ion, Na plus ion. Here 1 unit of positive charge. To neutralize 1 unit of positive charge, we need 1 electron. So 1 plus 1 minus get cancelled, and Na plus becomes Na. Okay. Actually, scientifically, we should not say this is a 1. It is not 1. Actually, it is 1 mole. So 1 mole of Na plus ions require 1 mole of electrons, and then we'll get 1 mole of sodium atoms. Okay. Here the charge of 1 mole electron is what? 1 Faraday. Okay. If I ask you what is the value of the charge we have used here? 1 Faraday, because 1 mole of electron means 1 Faraday. Okay, next one, Mg plus 2 electrons gives Mg. So Mg plus 2, here 2 units of positive charge requires 2 units of electrons. So we should not say it is 2 electrons, actually it is 2 moles of electrons. So what is the value of this 2 moles of electrons? 2 Faradays. Please note down 2 Faradays. Here 1 Faraday is required, here 2 Faradays are required. For what? To neutralize 1 mole of magnesium, 2 farads of current is required. Why 2 farads of current is required to neutralize 1 mole of magnesium? Because magnesium charge is plus 2. Okay. Similarly, one more example, Cu plus 2 plus 2 electrons. It's not 2 electrons, actually 2 moles of electrons. For the neutralization of 1 mole of copper, we need 2 Faraday of current, right? Then it becomes Cu. Next, aluminum. This you can say easily because you might have understood by this time. Aluminum, 1 mole of aluminum is Al plus 3. It is having 3 units of positive charge. It requires 3 units of 3 moles of electrons, means 3 Faradays of current. 3 Faradays means 1 Faraday is how much? 96,500. This is 2 into 96,500. Here 3 into 96,500. That's all. So you will understand this in our coming discussion also. Next, quantitative aspects of electrolysis. Quantitative aspects of electrolysis. That is a very important topic that now we are going to enter into Faraday's laws. Michael Faraday was the first scientist who described the quantitative aspects of electrolysis. What is quantitative analysis? Quantity means what? Quantity means the amount of the substance. How much amount of the substance is deposited or yielded during the electrolysis process. This has been extensively studied by Michael Faraday, okay, in the year 1833 and 34, so long back, when there was no technology and there was no science, much what to say, development of science and all. So Michael Faraday is one of the most inspiring scientists, and he has come from very humble family. Okay. Now, there are two laws of Faraday's, that is first law of Faraday of electrolysis, second law of Faraday's electrolysis. So Faraday has proposed, based on his experimental results, Faraday's first law and Faraday's second law. Now we are going to discuss what are these laws and what these laws are saying about electrolysis. So first let's discuss about first law of Faraday, or Faraday's first law. So to make you understand, and one second. Okay, dear student, here one small question to you. All of you listen carefully and try to give me an answer. Here I will give you two cases. Case 1, case 1. So in case 1, what I am going to do, I am going to take one beaker. I have taken some substance, say for example, sodium chloride, NaCl I have taken. I have arranged electrodes, and this is battery. When I switch on the battery, electricity passed into the beaker, that is into NaCl. Then NaCl splits into Na plus and Cl minus ions, and Na plus cations move towards cathode, and they will be deposited. Cations move towards cathode and they will be deposited at a cathode. Next, Cl minus ions are anions. Anions will be deposited at a anions will be released at a anode. Actually, here I say this is metal, no? Sodium is metal, no? So in the case of metal, I say deposited. Where this cations deposited? At cathode. What is cathode? Negatively charged electrode. Here, say for example, Na plus ions will be deposited here. One second. Na plus ion will be deposited here, that red mark. Okay. Here Cl minus ions are anions. Anions, chlorine now, Cl minus. So chlorine gas will be released. Chlorine gas will be released at anode, because that is an anion. So two products will be formed here. One is sodium, second one is chlorine. Since sodium is a metal, metal will be deposited at cathode because it is a cation. Non-metal is anion, so it will be released. It will be released. Why I am saying released? It is a gas, no? So chlorine released in the form of chlorine gas at anode. So just a few minutes back I told you metals deposited at generally metals will be in a positive charge and they will be deposited at cathode. Non-metals will be at anode, right? Once more, here two questions I am going to ask you. The question number 1, in the first case, if I pass less amount of current through the solution, then what happens? Second case, if I pass more amount of current through the solution, then what happens? That means you have to answer whether in the first case more sodium will be deposited, or less sodium will be deposited, or equal amount of sodium will be deposited. That means in the first case we have passed less amount of current. In the second case we have passed more amount of current. Where this is a electrolytic cell. Here is a battery. By using this battery, in the first case we have sent very less quantity of current. In the second case we have sent more quantity of current. In which case more sodium will be deposited?
Sir, more sodium will be deposited in the case 2, I think.
Yes, good. Because it's a very just a common sense question. Means generally what we think, when we send more current, more sodium will be deposited. When you send less current, less amount of sodium will be deposited, isn't it?
Yes,
So
yes, sir.
same thing was observed by Michael Faraday. So he has also observed the same thing, and he said he proposed the first law of Faraday. So what is first law of Faraday? Now let's go through the statement of Faraday's first law. According to Faraday's first law, the amount of substance that deposited or liberated. We use the term deposited for metals, liberated for gases, non-metals. The amount of substance deposited or liberated at any electrode during electrolysis is proportional to the quantity of electricity passed through the electrolytic solution. So try to understand the definition. So what is the main meaning of this definition? See, the amount of substance, I'm reading here. The amount of substance deposited is directly proportional to quantity of electricity passed. That means if we pass less quantity of current, less amount of current, less amount of substance will be deposited. If we pass more quantity of current, more amount of substance will be deposited. That's all, very simple. That's the Faraday's first law. When it comes to scientific definition, the statement will be like this: the amount of substance that deposited or liberated at any electrode during electrolysis is proportional to the quantity of electricity passing through the electrolytic solution. Okay, its mathematical representation we'll see here. Q means quantity of electricity in terms of coulombs. Small m is mass of the substance. How these two are related? Q is the quantity of electricity, m is the mass of substance. So both are directly proportional, no? So mass is directly proportional to quantity of current. Mass is directly proportional to quantity of current. This is a very simple form of Faraday's first law. If you can define this, if you can state this, and that's the Faraday's first law. See how I am going to give the statement of Faraday's first law. M is the amount of substance, mass of the substance deposited or liberated at any electrode. That is M. What is M? The M is the amount of substance or mass of the substance, M for mass, that deposited or liberated at any electrode during electrolysis, that is M, is directly proportional to Q. What is Q? Q is the quantity of electricity passing through the electrolytic solution. That's all. If you can state these two, this relation, then this statement will come automatically. So M is the amount of substance deposited during electrolysis process is directly proportional to quantity of current passing through the electrolytic solution, right? Now let's remove this proportionality. If you remove the proportionality, we will use some constant. See here, M is equal to, I hope you are note down, you are noting all these points. So this compulsory, you must note down all these things, because you just watch the video or just listen the class, nothing will happen if you don't note the things. So mass is equal to E into Q. Here proportionality is removed. Here E is a proportionality constant. Actually, it is called electrochemical equivalent. Come on, E is called electrochemical equivalent, ECE, electrochemical equivalent, ECE. Okay, it has a lot of importance that we'll discuss in the coming lecture. And in textbooks, in some textbooks, in the place of E, Z is mentioned. Z. Don't be confused. And E and Z, the meaning is same. That is electrochemical equivalent. Here Q is what? Q is quantity of electricity in coulombs, no? And in physics, you might have studied quantity of current in coulombs is equal to current in ampere into time in seconds. 1 coulomb is equal to 1 ampere current per second. Okay, per second. That is coulomb. So instead of Q, we can also write IT. Q can be replaced by IT. What is I? I is current in amperes. T is time in seconds. So in the previous formula, this M is equal to EQ, no? Come on, note down. M is equal to EQ, no? In the place of Q, what we can write? IT. What is the difference? If current is given in coulombs, then we have to write this formula. If current is given in terms of amperes and time also given, then we have to use the next formula that we are going to see here. M is equal to ECT. ECT. Here again one small confusion we may get. E means electrochemical equivalent. C is current in amperes. That is I you can write. You can write I, you can write C. Okay, don't be confused, my dear students. So M is equal to ECT. I will give different forms. Note down. M is equal to ECT. M is equal to ZCT. Okay, M is equal to ZIT. Here in the place of C, you can write I. In the place of E, you can write Z. Okay, don't be confused. And here one more most important formula. M is also can be written as ECT by 96,500. Okay, why we have got suddenly this form? Actually, here E is the no electrochemical equivalent E. This electrochemical equivalent E is equal to capital E by 96,500. Note down. Small e, that is electrochemical equivalent, is equal to E by 96,500. What is capital E here? Capital E is equivalent weight. Capital E is equivalent weight. So this part equivalent weight also very important. In the previous classes, here and there, I have given equivalent weights of few elements in the previous classes. Okay, no need to worry. If you don't know, you no need to worry. And in the coming classes also, we'll discuss equivalent weights of some important elements that you must know. Okay, this is all about Faraday's first law, right?
Sir,
And
have a small.
come on.
Sir, we used the term liberated also in the definition, right?
Yes.
And we said it's an electrolytic solution. In solution, how can it be a gas? You said liberated the word, it can be used for gases.
Yes. Yes. Okay. Your doubt is how can a gas will be liberated from a solution? That's yours.
Yes,
Right. Okay. What's the formula of water?
H2O, sir.
H2O. What are the elements in water? Hydro.
Hydrogen and oxygen, sir.
What are the basic physical forms of these elements? Hydrogen. You-
H2 and O2, sir.
Okay. Hydrogen, fundamentally, hydrogen is a gas, liquid, or solid?
It's a gas, sir.
It's a gas. Oxygen also?
It's
Gas.
a gas.
gas. Hydrogen and oxygen combined together will get water, isn't it?
Okay, sir. Yes, sir.
Both are gases, but when they combine together, we get water, which is in liquid form.
Okay, sir.
How can we get? Due to intermolecular interactions, that is hydrogen bonding.
Yes, sir.
Intermolecular hydrogen
Intermolecular.
bonding. Okay?
Okay, sir.
Getting the point? And when you pass electricity through water, then these hydrogen bonds will be broken.
Okay, sir.
When these hydrogen bonds are broken, then hydrogen and oxygen gets their original physical form. Hydrogen releases in the form of gas. Oxygen also releases in the form of gas. Similarly,
Yes.
if you take sodium chloride (NaCl), in sodium chloride, sodium is metal, chlorine is
And
chlorine is non-metal. Generally, it will be in a chlorine gaseous form, isn't it?
yes, yes, sir.
But when they combine together, they combine due to ionic bond,
And
Na
yes,
plus
sir.
Cl minus. When this bond is broken, again they'll get their
There,
original physical
there is
forms.
there.
That's the reason. Okay.
Okay, sir.
Right. Within few minutes, our class may be ended. 6 minutes left. So you please rejoin and we'll discuss Faraday's second law. By that, we'll end the class. So just few minutes it takes, not much, not more than 5 minutes. Okay. Right.
Okay,
This
sir.
is about Faraday's first law. Now we are going to discuss one simple formula, that is one simple problem, one numerical based on this Faraday's first law. So you be perfect with this form. M is equal to ECT by 96500. Okay. What is here? M. What is M here? M is the mass of the substance deposited or liberated. E is equivalent weight. C is a current in amperes. T is the time in seconds. Okay, by 96,500. Okay, remember? Right. One small question. If you want, you can note down. Otherwise, note down fastly. Otherwise, take a screenshot. A solution of copper sulfate. This problem is from your textbook, and this question is asked many times in board exams as well as competitive exams. A solution of copper sulfate is electrolyzed. Electrolyzed means we have sent electricity through the solution of copper sulfate for 10 minutes with a current of 1.5 amperes. So what is the quantity of current we sent? 1.5 amperes. You remember one thing, when the current is used in terms of ampere, we have to use the second formula of Faraday, first law. What is the mass of mass of copper deposited at cathode? What we have to find? The mass of copper deposited at cathode we have to find, right? So let's go through the solution. At cathode, copper will be deposited. So generally copper will be in the form of Cu plus 2. Cu plus 2 electrons gives Cu. This is its reduced form, reduction. So here how many electrons Cu plus 2 required? Cu plus 2 required 2 moles of electrons, isn't it? 2 moles of electron. That means its valency of copper is 2. Valency of copper is 2. Right? Now, equivalent weight of copper. So, what is the formula for equivalent weight? Equivalent weight of any element is equal to its atomic weight by valency. Atomic weight by valency. You must remember, you must by heart these values. Copper atomic weight 63.5 and valency of copper is 3. If possible, I'll take one separate class on valency, valence electrons. This is actually very fundamental topic. I already recorded regarding valency and valence electrons, but in Telugu. If you can understand Telugu, you can go to my channel and watch. Otherwise, if possible, after the class, I will send the link, share the link in our WhatsApp group. Right. This is what's the value of this? 63 point. Okay, I'll come back. Equivalent weight of copper is 63.5 by 2. It comes approximately 31.75. 31.75. But in solving problems, we'll take this value as 32. Equivalent weight of copper is 32 approximately. Remember. Next, time is given 10 minutes. in the problem, given problem, time is given 10 minutes, but we must convert the time into seconds. So 10 minutes into 60. Why? Minutes are converted into seconds by multiplying with 60. So 10 minutes into 60, that is equal to 600 seconds. What is the current is given in amperes? 1.5 amperes. So now you got everything. You got everything now. So what is the formula? M is equal to E into CT. Here what he has done, okay, I'll change this. Do you understand this? Okay, I'll come back. So I'll open my tab. So I hope you are writing all these things. See here, M is equal to ECT by 96,500. That is equal to, what is equivalent weight of copper? Equivalent weight of copper, I told you, 32, approximately 32. Actually it is 31.75. So but I am taking it as 32. What is current? Current is 1.5 amperes into, what is the time? Time, just I told 10 minutes given in the problem. We have converted into seconds. 10 into 60, that is 600 seconds. Time is 600. So E is equivalent weight is 32. Current is 1.5 amperes. Time is 600 seconds divided by 96,500. So dear students, I do one thing here. Uh, uh, Mostly, one second. Okay, it is time is less than 1 minute. Okay, I'll go a little fast. See here, this is 32 into 1.5. Can we shall we write 3 by 2? 3 by 2 into 600, and again divided by this 96,500. 96,500, I am going to take it as approximately 1 lakh. 96,500, I am going to take it as 1 lakh, that is 10 power 5. 10 raised to 5. 10 raised to 5. Then it becomes 2 ones are 2, 16s are. Here 10 raised to 5, no? Here 2 zeros are there. Here 2 zeros you can cancel. Then it becomes 3, 10 cube. What are left? Here 16, here 3, here 6, here 10 raised to 3. Okay. Dear students, I'm continuing this. So we'll get approximately here 16 threes are here in the numerator, 16 into 3 into 6 into here 10 raised to 3 is there, no? If you take that into numerator, this becomes 10 raised to minus 3. So if you multiply all these things, and you will get some approximate value. 16 threes are 48 into 6. 6 eights are 48. 6 fours are 24 for 28. So 288 into 10 raised to minus 3. That becomes approximately 0.288. 0.288 grams. So this is approximate value. Why I have taken this way means, here 96,500 is a huge value. But in competitive exams, generally whenever you want to modify this value, you want to calculate this value, take this 96,500 as a 1 lakh, that is 10 power 5, so that you will get the answer little quickly, right? We'll go to the slide PPT. One second. So this is the problem given. So we have substituted everything. 63.5 by 2, that is actually equivalent weight by 900. 0.29. Here is the answer. What is the answer we got? What is the answer we got? What's our answer? Our answer is 0.288. 0.288. That is nothing but 0.29, no? 0.29 approximately. So approximate value we get. Suppose in a competitive exam you will have some objective, that means A B C D options will be there. So you choose the correct option, right? So this is how we can easily calculate, and this is one problem. Next, second law of Faraday. Faraday's second law. So before going to get this statement and all, I'll explain you briefly, then we will go to PowerPoint presentation. So now I'm going to take two or three beakers. I've taken three beakers. First beaker is filled with, say for example, silver nitrate solution. Second beaker is filled with magnesium sulfate MgSO4 solution. And third beaker is filled with, say for example, copper sulfate solution. These are all different solutions. Now what we are going to do, and we are connecting all these solutions with some external wire. These are the electrodes, and these solutions are connected through some external wires. This connection is called a series connection. This connection is called series connection. You might have studied about series connection and parallel connection in physics. What is the means specialty or difference? How series connection is different from parallel connection? So in series connection, so here three different beakers we have taken now, and all these are interconnected. So whatever the current we are passing through the first solution will be equal to in all the three solutions. The current is same in all the three solutions: AgNO3, MgSO4, CuSO4. So what is Faraday's first law? In Faraday's first law, we discussed that when we take a beaker and one solution, electrodes, battery, and when we use less quantity of current, less amount of substance will be deposited. When we send more quantity of current, more amount of substance will be deposited. That means mass of the substance deposited is directly proportional to quantity of current passed. That is first law. Now in second law, this case is different. We have taken three or four different electrolytic solutions. Different electrolytic solutions we have taken, and but we are using same quantity of current. Because why same quantity of current? This is a series connection. Whatever the current passed through the first beaker, that is for first solution, will be equal to the second, will be equal to the third container. So the same quantity of current is passed through all the three containers. In such case, what about the mass of the substance deposited? Mass of the substance deposited in the first container, mass of the substance deposited in the second container, mass of the substance deposited in the third container. How they are related? So then Faraday observed that the mass of the substance deposited in first container by equivalent weight of the first container is equal to mass of the substance deposited in the second container by its equivalent weight. That means mass of the substance and equivalent weight of one substance will be equal to mass of the other substance and its equivalent weight. Mass by equivalent weight. This was observed by Michael Faraday. So this can also be written as, you see, you can interchange this, and E and M2 you can interchange. Then it becomes M1 by M2 is equal to E1 by E2. You can also write like this. This is Faraday's second law. So what we can say from this? Mass is directly proportional to equivalent weight. Mass of the first substance here, mass of the first substance is directly proportional to equivalent weight of the first substance. Mass of the second substance is directly proportional to equivalent weight of the second substance. Okay, that means here the case is different. When two or three different electrolytes are connected in series, then the amount of substance deposited will be directly proportional to their equivalent weights. See, this is the statement. If the same quantity of electricity is passing through the different electrolytic solutions, same quantity of electricity means they are connected in series, then same quantity of current is passed through different electrolytic solutions, then the amount of substance deposited, or liberated is proportional to their chemical equivalent weights, So here a small picture is showing. So three different electrolytes and are connected in series, then same quantity of current is passed through this, then let M1 and M2 are the masses of the first and second substances. E1 and E2 are their equivalent weights. Then, according to Faraday's second law, M1 by M2 is equal to E1 by E2, or can also be written as M1 by E1 is equal to M2 by E2. Try to remember this formula, and it's also very important. And we'll see any question based on this. And just for 4 or 5 minutes, after that, we'll conclude the class. The two electrolytic cells containing 0.2 m means molarity, concentration, ferrous sulfate and 0.2 m ferric chloride solutions. See here, small difference, ferrous sulfate, ferric chloride. What is the difference between ferrous and ferric? Concentrations are same, 0.2, 0.2. Ferrous means Fe plus 2. Ferric is Fe plus 3. So, ferrous Fe plus 2, ferric Fe plus 3. Means valency of ferrous iron is 2, ferric valency of iron is 3. Valencies are different. Ferrous plus 2, ferric plus 3, right? Now, the question is subjected to electrolysis. The ratio of weight of iron deposited in the two cells under the same time is. Then what is the ratio of iron deposited in the two cases? Here different options are given. 1:1, 2:1, 3:1 and 3:2. So here which law we have to use? Faraday's first law or second law? See here, two electrolytic cells containing 0.2 m ferrous sulfate, 0.2 m ferric chloride solutions respectively subjected to electrolysis. Okay. Then what is the weight ratio? So here two substances, same substance of different valencies are given. Then equivalent weights. We have to find their equivalent weights, right? Weight of the iron deposited. See, 3:2. Why 3:2? Here solution. Faraday, according to Faraday's second law, the ratio of weights. Just you get the formula. What is the formula? Just we discuss. M1 by M2 is equal to E1 by E2. Don't be confused. Here W is used. W is nothing but weight. In the formula we have used M. M and W both are both give same meaning here. So M1 by M2. That means ferrous, mass of ferrous by mass of ferric is equal to equivalent weight of ferrous by equivalent weight of ferric. That is equal to equivalent weight of ferrous. Equivalent weight formula, atomic weight by valency. Atomic weight of iron is 56, valency is 2. Why valency 2? So ferrous. By divided by equivalent weight of ferric. Equivalent weight of ferric means atomic weight by valency. Atomic weight 56 by valency 3. And 56 get cancelled. This is a 1 by 2 and 1 by 3. 1 by 2, 1 by 3, if you do cross multiplication, or if you take this denominator part to the numerator, it becomes 3 by 1. 1 by 2 into 3 by 1, that is 3 by 2. So that's the ratio. So it's a simple problem. I hope you understood that. If you don't, you can ask me once again, I will explain. Okay. The number of coulombs required to deposit 5.4 grams of aluminum when the given electrode reaction is represented as. See here, 5.4 grams of, to deposit 5.4 grams of aluminum, how much current, number of coulombs of current we required. So this is a simple but important formula. So can you tell me what is the valency of aluminum? Valency of aluminum is 3. No. The amount of 1 Faraday, all of you, please note down this statement. 1 Faraday, note down this statement. 1 Faraday deposits 1 gram equivalent weight of the substance. 1 Faraday is equal to 1 gram equivalent weight. So I will explain on the tab. I'll take my tab. See, just to make you understand, I am equivalent weight of sodium is equal to atomic weight of sodium 23 by valency of sodium 1. So 23 grams. Equivalent weight of magnesium. Magnesium Mg plus 2, no? Atomic weight of magnesium 24, valency 2, 24 by 2, 12 grams. Equivalent weight of magnesium 12 grams. Equivalent weight of aluminum Al plus 3. Sorry, Al plus 3. So aluminum atomic weight 27, valency 3, 27 by 3, 9 grams, and so on. Equivalent weight of copper, just a few minutes back we have seen copper Cu plus 2. Copper atomic weight 63.5 by valency of copper 2, that is 31.75, or approximately we will take 32. These are the equivalent weights of different substances. Now shall I tell you one interesting point, that to get 1 Faraday of current, if you use 1 Faraday of current, that is 96,500 coulombs, 96,500 coulombs, it gives 23 grams of sodium. And 1 Faraday of current gives how much magnesium? 12 grams of magnesium. 1 Faraday of current gives how much aluminium? 9 grams of aluminium. 1 Faraday of current gives how much copper? 31.75, that is approximately 32 grams. That means 1 Faraday of current always gives 1 gram equivalent weight of the substance. 1 Faraday gives 1 gram equivalent weight of the substance. So it is must and should, you must and should know gram equivalent weights of the substances. Suppose if I ask you what is the gram equivalent weight of sodium, you have to say 23 grams, or magnesium 12 grams, aluminum 9 grams. These are gram equivalent weights. What are gram equivalent weights? Equivalent weights is equal to atomic weights by valency again. Okay, atomic weight by valency. These values we must know. But you no need to worry. Only few elements are there which are more important. That is sodium, magnesium, aluminum, copper, silver, okay, iron. These are the important elements. If you remember these, enough. Okay. Now let's go back to the PPT. So this is the problem given. See here, we need to get 5.4 grams of aluminum. So how much current we need to send? So for this, basically, fundamentally, you have to know few things. If I ask you 9 grams to get 9 grams of aluminum, how much current we need to pass? To get 9 grams of aluminum, how much current we need to pass? Just I told you, no? To get 9 grams of aluminum, we need to pass 96,500 coulombs, because 9 grams is its equivalent weight. So 96,500 coulombs gives 9 grams of aluminum. Then our question is how much current is required to get 5.4 grams of aluminum. That is our question. That's all very simple. You do cross multiplication. So let it be x. X coulombs. We don't know this. Do cross multiplication. X into 9. So our 9x is equal to 96,500 into 5.4. 96,500 into 5.4. Just I told you take 1 lakh in the place of 96,500. Then 9x is equal to 10 to the power of 5 into 5.4. Then what is the value of x? X is equal to 10 power 5 into 5.4 by 9. So you must know 9 table. 9 ones are 54. It looks like 54 now. 5.4 looks like 54 now. In which table you will get 54? In 9. 9 5s are 45. 9 6 are, sorry, 9 6 are 54 now. So it is 5.4, so 0.6, that is equal to 0.6 into 10 raised to 5, 6 into 10 raised to 4, that is 6. Okay. So what's the answer? One second. Okay, yes. We are getting 60,000 now. 60,000. Here the answer is 57,900. 57,900. We are getting 60,000. Both are approximately same now. Nearly equal now. Why we are getting 60,000 and here 57,900? Because we have taken that 96,500 coulombs into 1 lakh. So we have got little more value. So approximately 57,900. That's all. So this type of questions we are getting. So solution is see here. According to first law of Faraday, 96,500 here. 9 grams of aluminum deposits. 9 grams of aluminum deposited by 96,500 coulombs. Why this? Why this? So 9 grams is the equivalent weight of aluminum, and that can be deposited by passing 96,500 coulombs. Means 1 Faraday. 1 Faraday deposits 1 gram equivalent weight. And next class, tomorrow's class, I'll continue this topic only, because I want to make you perfect with equivalent weights. Then only you can answer these type of questions easily. Okay, we'll repeat the same topic once again, and then we'll continue the different electrolytic process and the different substances, deposition of different substances during electrolysis process. That's also important, and we'll continue in the next class. See here, 9 grams of substance deposited by 96,500, then 5.4 grams deposited by 96,500 into 54 by 9. So we'll get approximately, that is exact answer is 57,900, and we are getting approximately 60,000. Okay. Okay, dear students, by this we'll end the class and we'll meet in the tomorrow's class. Okay, you just go through the statements and formulas and these equivalent weights and all. And tomorrow, once again, I'll continue. If possible, 2 or 3 more numericals we'll discuss on Faraday's first law and second law. Okay, I will meet in the next class. Good night. Take care. Bye bye.